Hi guys, let's talk about another very important concept in statistics. It's called standard deviation. So let's actually see what does standard deviation depict or what does it imply. So standard deviation depicts the dispersion of the set. It talks about how dispersed or how scattered the values in a particular set are. More scattered the set, greater the standard deviation. What does that mean? If the values are very far away from each other, standard deviation would be greater. If the values are very close to each other, standard deviation would be smaller. So for most practical purposes, for most of the questions that you might expect on your exam pertaining to standard deviation, most of the questions would not require you to calculate standard deviation. Just by comparing the two sets, you can see, okay, maybe this set is more dispersed than the second set. So the standard deviation of the first set has to be more than the second set. So most of the questions can be answered like this. Let's have a look at one very basic example. Let's say the set 1 consists of terms 1, 11 and 21. And the set 2 consists of terms 101, 102 and 103. As we talked about, standard deviation is a function of dispersion or scatteredness of the values in the set. So which set has more scattered values? That would be set 1. In set 1, the terms are 10 apart from each other, right? The difference between the terms is 10. So they are more dispersed. In set 2, though the terms are larger, they are much larger compared to the terms in set 1, but the magnitude of the terms has nothing to do with standard deviation. It's the dispersion between the terms. So obviously the terms in set 1 are much closer to each other, so standard deviation of set 2 would be smaller. So what I can conclude from this is standard deviation of 1 is greater than standard deviation of 2. As I said, for most of the questions that you might expect on an exam, just by comparing like this, you can figure out the correct answer. But still, it's important to learn how to calculate standard deviation. Let's have a look at that. Let's say I want to calculate the standard deviation of a sample set 1, 3 and 5. Let's first understand that calculating standard deviation is a 5-step process. Let's have a look at those steps. Step 1 is calculate the mean of the set. Step 1 is to calculate the mean of the set. So what is the mean of this sample set? 1 plus 3 plus 5 by 3 or 3. So mean of this set is 3. That's the first thing that you need to calculate. Second step is for every term, calculate its difference from the mean. So for every term in the set, calculate that term's difference from the mean of the set. So for 1, the difference from mean 3 is 2. For 3, the difference from the mean 3 would be 0. For 5, the difference from the mean 3 is again 2. The step 3 is square the differences that you obtained in step 2. So squaring 202, we get 404. Step 4 is to calculate the average of these squares. So 4, 0 and 4, average of these three would be 4 plus 0 plus 4 by 3 or 8 by 3. And the last step, take the square root of the average. So the average is 8 by 3, square root of that. Square root of 8 by 3 is the standard deviation of the set. So this is how we go about calculating standard deviation. Now let's have a look at a few properties pertaining to standard deviation. Property number 1 says, adding or subtracting a constant from each term does not change the standard deviation. So if I were to add the same constant, if I were to subtract the same constant from each term, that has no impact on the standard deviation. Property number 2 says, multiplying every term by a constant results in standard deviation getting multiplied by the absolute value of the constant. We'll have a look at what this actually means. Property 3 is very similar to property 2. It says dividing every term by a constant results in standard deviation getting divided by the absolute value of that constant. There's a note here. Range follows the same properties as standard deviation. So whatever are the properties of standard deviation, range also follows the same properties. Now let's have a look at what these properties actually mean. Let's depict them with a sample set, with the help of a sample set. So let's say the values in a particular set are x, y, z such that their standard deviation is d and the range of the set is r. So a set contains 3 values x, y, z, standard deviation of the set is d and range of the set is r. Now if I add or subtract the same constant from each of these values, remember that does not have any change on the standard deviation. So the standard deviation is still D. Now because range also follows the same properties as standard deviation, the range rather also does not go through any change. The range of this set would still be R. Case 2, if I multiply each of these three terms x, y and z with a constant k, then the standard deviation gets multiplied with the absolute value of the constant, or the new standard deviation would be d into modulus of k. As I said, the new standard deviation gets multiplied with the absolute value of the constant, which is modulus of k. So the new standard deviation d into modulus of k. Now because the range also follows the same properties, the new range would be r into modulus of k. The third property, if I were to divide all the three terms by k, then the new standard deviation gets divided by absolute value of that constant. So the new standard deviation is d divided by modulus of k. And because range again follows the same properties as standard deviation, the new range would be r divided by modulus of k. So these were the properties of standard deviation and range.